Hello everybody. Lesson 8, Organics, Polymers utilized in construction. Introduction. In this chapter, we look at the main polymer materials and their application in civil engineering and construction application. The following are the most commonly utilized polymer materials in architecture, construction, or civil engineering application. Fundamental chemical properties, main mechanical properties, and practical applications are discussed. Polymer materials account for the highest growth area in construction materials. In basic terms, polymers are very long molecules typically made up of many thousands of repeat units. They include plastics, rubbers, thermoplastic elastomers, adhesives, foams, paints, and sealants. And what is the polymer in engineering? Engineering polymers are a group of plastic materials that have improved mechanical and thermal properties that make them ideal for all types of engineering applications, replacing traditional materials equal or greater in weight, hardness, or other properties, while being much simpler to manufacture, especially with complex shapes. And what are the application of polymers? Clothing, floor covering, garbage disposal bags, and packaging are other polymers applications. Automobile parts, windshields for fighter planes, pipes, tanks, packing materials, insulation, wood substitutes, adhesives, matrix for composites, and elastomers are all polymer applications used in the industrial market, in construction. And what are polymers? Polymers become the raw materials for products we now use every day, including synthetic clothing, fiberglass, plastic bags, nylon bearing, polyethylene cups, epoxy glue, silicone heart valves, Teflon coated cookware, and our personal favorite, polymer based paints. So, polymers in civil engineering. Poly and meros equal many parts. Monomer equal non-linked mer material. And polymer equal long continuous chain molecules formed from repeated sequences of small organic units, MERS. Construction and utility parts in buildings are often partly or completely polymeric or elastomeric products. This can be as wall panels, roofing materials, piping systems, seals, coatings, and a large number of other products. Structure of monomers and polymers. Monomer. A monomer is a small molecule, and polymer is a long chain molecule made up of a repeated pattern of monomers. Polymers used in a variety of applications. Polyethylene, unplasticized polyvinyl chloride, ethylene, propylene, DIN rubber, melamine, and other. This is the most widely used polymeric materials in the world. A molecule of polyethylene is a long chain of carbon atoms with two hydrogen atoms attached to each carbon atom. The chemical formula is CH2, and in construction applications include interior plumbing pipes as cross-linked polyethylene and waterproof sheets for damp-proof applications, as polyethylene is impermeable to the passage of water. Polyethylene is available in many different densities which determine its application. Polyethylene is classified into several different categories based mostly on its density and branching. The mechanical properties of polyethylene depend significantly on variables such as the extent and type of branching, the crystal structure, and the molecular weight. Polymerization is the use of heat, pressure, or a chemical catalyst to link monomer material into polymer chains. So, from monomers, using polymerization, we find polymer. Plastic types. Thermosetting plastics, 20% of production. That include a polymer material that cannot be reformed after manufacturing, cross-linked chain networks, less creep, isotropic, good structural properties, injection molded. And the thermoplastics, it's 80% of production. And thermoplastics are a polymer that can be remolded after manufacturing, softens upon reheating, substantial creep, isotropic properties. Extrusion, PVC pipe, or molding, PET soda bottles. Thermoplastic and thermosetting plastic. The primary difference between the two is that thermoset is a material that strengthens when heated, but cannot be remolded or heated after the initial forming, while thermoplastics can be reheated, remolded and cooled as necessary without causing any chemical changes. And what are thermoplastics and thermosetting plastics give examples? What are examples of thermoplastic and thermosetting plastics? Some common thermoplastics are polyethylene, PVC, polystyrene, nylon, and acetate. Epoxy resins are an example of thermosetting plastics. Examples of thermoplastic material are polyethylene, polyvinyl chloride, polystyrene, polyamide, polyesters, and polyurethanes. High temperature thermoplastics include polyesters ketones, liquid crystalline polymers, polysulfones, and polyphenylene sulfide. And here you can see a difference between thermoplastics and thermosetting plastics. Thermoplastics are usually formed by the addition of polymerization. It contains long-chain linear polymers and held together by weak van der Waals forces. Usually becomes soften on heating and stiffen on cooling. They're expensive. Thermoplastics is soluble in organic solvents. They are usually soft, weak, and less brittle in nature. Can be remolded. An example of thermoplastic is polyethylene. Polyethylene and thermosetting plastic are often formed by the condensation polymerization. It contains a 3D network structure constructed with strong covalent bonds. It doesn't become soft on heating. They are cheap. Thermosetting plastics are insoluble in organic solvents. They are usually hard, strong, and more brittle in nature. They can't be remolded. An example of thermosetting plastic is bakelite. Natural polymers. Natural polymers occur in nature and can be extracted. They are often water-based. Examples of naturally occurring polymers are wood, leather, cotton, rubber, wool, asphalt, also silk, wool, cellulose, and proteins. Polymers are widely found in nature. The human body contains many natural polymers, such as proteins and nucleic acids. Cellulose and other natural polymers is the main structural components of plants. Most natural polymers are condensation polymers, and in their formation from monomers, water is a byproduct. Cotton from plants is a natural polymer and is used to make clothing. Natural latex from rubber tree is a polymer. Crustacean shells are made of chitin, a natural polymer. Silk from silkworms is used to make clothes. Rubber can be used to make tires. Carbs like spaghetti are natural polymers. Wood is a natural polymer used for paper or rubber blends. Proteins from eggs and other foods are also natural polymers. Manufactured polymers. Manufactured polymers. The conversion of raw polymers into finished products involves a series of polymer manufacturing processes. Forming can be conveniently divided into two-dimensional forming, where products have a relatively simple geometry, and also three-dimensional forming with a complex geometry. And what are the synthetic polymers? Synthetic polymers are derived from petroleum oil and made by scientists and engineers. Examples of synthetic polymers include nylon, polyethylene, polyester, Teflon, and epoxy. Natural polymers occur in nature and can be extracted. Examples of manufactured polymers also polyesters, this is the thermoplastic or thermoset, epoxy, thermosetting, sulfur concrete, this is a thermoplastic, methyl methacrylate, MMA, polyurethane, polystyrene, this is a thermoplastic, polyvinyl chloride, thermoplastic, and polyethylene, also thermoplastic. The advantages are low cost, reasonable specific strength, chemical resistance, and ease of shaping into objects that are useful. And of course, synthetic polymers are mostly made from petroleum derivatives. So this is example of manufactured polymers. Epoxy. Thermosetting. Epoxy is thermosetting epoxide polymer that cures, polymerizes, and cross-links when mixed with a catalyzing agent or hardener. Epoxies are used as powder coating for a variety of applications. Fusion-bonded epoxy powder coatings are extensively used for corrosion protection of steel pipes and fitting used in the oil and gas industry. Portable water transmission pipelines or steel from steel, concrete reinforcing rebar, etc. Epoxy coatings are also widely used as a primer to improve the adhesion of paint, especially on metal surfaces where corrosion rusting resistance is important. Metal cans and containers are often coated with epoxy to prevent rusting. Epoxy resins are also used for high performance and decorative flooring applications, especially terracoflooring, chip flooring, and colored aggregate flooring. Epoxy adhesives are a major part of the class of adhesives called structural adhesives or engineering adhesives, which also includes polyurethane, acrylic, and cyanoacrylate. These high-performance adhesives are used in the construction industry as well as many other where high-strength bonds are required. Epoxy adhesives can be developed to suit almost any application. They are exceptional adhesives for wood, metal, glass, stone, and some plastics. They can be made flexible or rigid, transparent or opaque, colored, fast setting, or extremely slow setting. Epoxy adhesives are almost unmatched in heat and chemical resistance among common adhesives. In general, epoxy adhesives cured with heat will be more heat and chemical resistant than those cured at room temperature. Physical properties are strength and moduli vary with temperature and formulation. Thermal coefficient greater than concrete. Brittle behavior more brittle than concrete. Excellent adhesion. Tenacious bond. High tensile and compressive strength. Highly resistant to chemical attack and wear. Epoxy paints, these are a special type of paint which are highly resistant to abrasion and spillages of oils, detergent or dilute aqueous chemical. They are often applied to concrete, stone, metal, or wood in heavily trafficked workshops and factories. Disadvantages and limitations of epoxy. Properties are very sensitive to mixing and proportioning procedures. Some cannot be used in moist environments. Strong, allergenic, and safety. Some have strong odor prior to polymerization. Physical properties are substantially different from other materials.